This video is on completing the square to take a quadratic equation into vertex form. Let's get started. The first thing I want to do is to square these binomials and look for patterns. So what does it mean to square a binomial? Well, it means to multiply it by itself. So x plus 3 squared is x plus 3 times x plus 3. If I multiply x times x, I get x squared. X times 3 is plus 3x, 3 times x is 3x, and 3 times 3 is 9. If I combine like terms, I get x squared plus 6x plus 9. And I will do these other two binomials in the exact same way. If we describe these binomials, the ones we started with, as x plus d squared, and the resulting quadratic ax squared plus bx plus c, how is the b term, how is this 6 term related to this term that we started with? How is the negative 10 related to this term we started with? And how is the 18 related to this term we started with? Okay, you may notice that half of the b term is that starting d term. So half of b is equal to d. Now, the other pattern we need to look for is how is the d term related to the c term? How is this term related to that term? How is 9 related to 81? Well, that came from 3 times 3, and so I can square that d term and find the b term. Okay, those are some really useful patterns to notice as we are doing this process called complete the square. All right? The process of completing the square is turning any quadratic into a binomial squared plus or minus some constant. Okay, and so here's an example of that. I'll rewrite this. Y is equal to x squared plus 6x. I'm going to leave a space plus 5. And my goal is to complete, is to make this right here into a perfect square trinomial, something that is a binomial squared. Okay. If I were to get that into a perfect square trinomial, then it would have to be x, let's see here. The pattern we just looked at is that it has to be half of this term. Okay, half of 6 is 3. Okay, if it was going to work, it would be x plus 3. Okay, because if I expanded that out, I would get the x squared plus 6x that I needed. Okay, so what would this term have to be? Well, I also noticed that the term here is that 3 squared, so it must be a plus 9. Okay, so that pattern we saw before as half and then squared is really useful in this process. Okay, so x squared plus 6x plus 9 is exactly the perfect square trinomial that I need to make the square x plus 3 squared. But I just broke one of the rules of mathematics. Okay, I added 9 to one side of my equation without keeping it equals. So now it's no longer equals because I just put a plus 9 in there. So to compensate for that, I'm actually going to subtract that same amount over here. Okay, so I'm adding 9, but I'm also taking 9 away, and so it's equal and it stays even. Okay, so again, keep in mind that this right here, this trinomial, is this binomial squared, and then 5 minus 9 is negative 4. So this right here is in what's called vertex form. I've completed the square, and I have that equation in vertex form, which is a really convenient one for graphing a quadratic. So here's one more example of that process, a little bit more complicated, because now I've added in here an additional number, a coefficient, in front of x squared. So there's one more step to do in that process. Actually, that's two more steps for the whole process. The first thing I'll do is I will factor out that term, whatever it may be, out of these first two terms. And so I get y is equal to 2 parenthesis x squared. Now 2 times what is negative 8x? It's negative 4x. I'm again going to leave a space that I'll fill in later, and I'll leave my minus 1 out here. Okay? Now, if this trinomial, what's going to be a trinomial, was to be a perfect square trinomial, it would have to be x minus half of 4 is 2 squared. Okay, and that half that we noticed before, we're doing half of negative 4 is negative 2. Okay, because x minus 2 squared gives me the x squared and the minus 4x that I need. Okay, so what is this term? Well, it is negative 2 squared, which is negative 2 times negative 2, which is positive 4. Okay, now again, I've broken a rule. I've added something into the equation, so I need to subtract that same amount out so it stays equal. But that 4 isn't really a 4. Okay, it's inside parentheses. It's inside a grouping symbol, so actually it is 2 times 4. So really by putting that 4 in there, I have actually added 8 to this equation, right? So 2 times 4 is 8. So I've actually added 8 into the equation. So I must compensate for that to keep it equals by subtracting 8 out here. Okay? So don't forget that this term right here is this term. And so negative 1 minus 8 is negative 9. So again, this happens to be the vertex form of a quadratic, written as y equals a times the quantity x minus h squared plus k, where the vertex of the parabola, that like the bottom valley point or the top of the peak point, is the coordinates h, k. And in our next video, we will look at how to graph equations that are written in vertex form. Thank you for watching.